requested. Okay, so let's move on. Now, also, so aside from public and private, there are some specific ID addresses that are used for specific things. Yeah, they use them for specific things. So in short, they are set aside for those functions. They are set aside for those functions. So one of them is loop back addresses. Loop back addresses. So it's being used on a host to test if TCP IP is working. So if you want to know if TCP IP, take for instance, maybe you are connected to internet. Now, if you want to know if TCP IP is up and on running and all that, just ping this address, you will know. So that's what it's used for. Then also we have link local addresses is being used in DHCP. So later on, we'll still talk about what is DHCP and all that. So now, basically now, you can either have, you can decide to take note of this. When we are talking about IP addressing, now it may be a classful addressing or a classless addressing. So which we will explain later. We'll still see what a classful IP address look like. This is a classful addressing, and we'll know what it means to say we have classless IP address. So now, but for the classful IP address, now we have them as class A if they are between the range you can see over there, 0.0.0.0 to 127.0.0.0. Then class B within the other range, class C within that range, class D within that range. So class D and class E, I think one is as used for research. So there are some IP addresses that are researched for reserved for research purposes. They are reserved for research purposes. So, but ABC is available. Yeah. But when we are talking about this class of a thing, we are just talking about classful addressing. When we are trying to talk about classful addressing. But when we start talking about classless addressing, then this rule does not apply. So don't let me, I'm not confusing you. Basically, an IP address can either be private or public. Also, there are some specific addresses that have been assigned for specific purposes. Now, when we are talking about addressing, it can either be classful or classless. So for classful, there are basically 5 classes. While for classless, there's no rules. There's no rule around it. There's no rule around it. So let's progress. So now all these IP addresses and all that, there are agencies, there are authorities that manage IP addresses. A very, very precious commodity. Let me put it that way. So across the world, so in Africa, we have the Afrinic. They are the one in charge of allocating IP addresses to ISPs. So ISP are internet service provider. They are those public addresses we talked about that they are very, very precious. You can't just have it. That's why you can't just wake up today and say, I want to have my own internet. I want to be providing internet service for people. In short, the licensing and a lot of things you have to pay for and all that. So it's very, very expensive and very, very precious. So we have agencies, registrars, authorities across the world. So these are, the AFRIN is for, I think that's for US and North America. I think that's North America, yeah, those are US. They have LACNIC for South America and so on, and so on, and so on. So let's proceed. So let's look at network segmentation. So hope you are not tired. In short, I'm the one teaching. I should be the one say, hope I'm not tired. Nobody's fully responding. Can you hear me, please?
Yes, we can hear you, sir.
Okay. Thank you. Okay, so broadcast, domain, and and segmentation. So where and in what cases do we, when we say we talk about broadcast domain and all that, we've talked about unicast transmission, broadcast transmission, and multicast transmission. And we know what they are used for. So take for instance, if you are dealing with a layer 2 switch, now when we talk about layer 2 switch now, anything you plug on layer 2 switch also have, that's why if you get access to the switch in let me say the one in your HOD office, just plug your, if it's not a layer 3 switch, just plug a LAN cable and start using it. There's no any, you have access to every other thing that is connected to that layer 2 switch, because a layer 2 switch is within a broadcast domain. So it's when you are now doing layer 3 switch that, okay, you are now routing a particular set, particular network and all that. So routers don't do broadcast domain. So each port on a router is single. They don't, in short, if you plug on a port on router, if you plug on the other ports, they are not even seeing each other until maybe you try to route that network through to the other network. That's when they can now maybe exchange data. They can now see each other. So routers, they don't. So each port is a domain. Each port is like a domain itself. So, but when you talk about layer 2 switch, every port is a broadcast. So when we talk about this broadcast, that means if something is sent to one, others are receiving it. So that's what we mean by that. So what is now the problem with large broadcast domain? Now, we were talking about subnetting the other time. Now, just imagine that class full addressing. Now, imagine you design a network that has about let's say, that can accommodate 2,000 hosts, but you only need just maybe 3 hosts in that network. It's an abuse actually, and it can overburden the capacity of the resources, how you've designed it. If you just keep the domain that's like that broad, and that's what leads us to when we start talking about subnetting. So we try to miniaturize, we try to segment the network. I know if you have been given a bigger, let's say, I don't want to use the bigger, an IP address, you can subnet it and divide it into, like, you can bring out, let's say, 500 networks. Yes, out of a single IP address. Very, very possible. Very, very, very possible. So that's what subnet brings in. It reduces overall network traffic and improve network performance. It is used to implement security policies between subnets. Yes. Subnetting reduces the number of devices affected by abnormal broadcasts. Yes, that I just said. So when you have an IP address, you can subnet it. And that's what happens with those ISPs. They may get a particular IP address, but they will subnet it to as many that want to use it. They will subnet it. So this is just an instance, just like the instance we have here. Look at that location now. Right? It's just like a building. There are different local area network on each floor of the building. But on the outside, like we've talked about NAT, the NAT, there's a single IP address that is being known with the organization. So that single IP address, I can, okay, let's not talk about that one. But using subnetting, I can put the different floors on different networks. So we learn that and we know the techniques. So subnet and IP version 4. How do we go about it? So networks are mostly easily subnetted at the octet boundary of 8, 16, and 24. Yes, that which you are familiar with. So if I say an IP address /8 now, you know, okay, the first 255 is gone, and you can, but you can go beyond that. So notice that using longer prefixes length decreases the number of hosts per subnet. Yes, please kindly take note of this. Kindly take note of this. Now, we are just trying to look at it holistically now. Like a classful address now. So the /8 is like that's class A, class B, then class C. So you can see that on class A, you can see the one written with NNN. So that means I can have 2 raised to power 1, 2, 3, 4, 5, 6, 7, 2 raised to power 8 network in that subnet, and I can have 2 raised to power 2 raised to power 24, which will give you hosts. So I can have 2 raised to power 24 hosts from this /8. So the same thing with /16, 2 raised to power 16, 2 raised to power 16. So, but in some cases, you want to be more defined than this. You don't need 254 hosts. You don't need 60,000 hosts. You don't need too many subnets. So that's what classless has come to do. And that's what we are talking about, subnetting. So let's look at the first table. The first table, 10.0.0.0/8 is subnetted using /16. Okay. Okay, no comment. Okay. Some are just joining us. Okay. So now let's try to do some subnetting. So now I will call someone who has been in the class since we started. I will ask a question, and we are going to be doing this together. So now the thing is, we are 10.0.0.0/8, but we want to subnet it using /16. So what does that tell you, Edison? If I'm using /16, what does that tell you?
And it means like it's increasing from 255.00 to 255.255.0.0.
I did not understand that. Can you come again? Sorry. Or someone else who, when we say /16, based on what I've explained, now, from what I explained, please don't always forget. Okay. Like it will be 255.255.0.0. Yes, that will be our, yes. You are correct. So the number of hosts now, yes. Oh, you guys are super brilliant. Hey, I want to be like you. So the number of hosts we'll be having will be 2 raised to power 16 minus 2. Who can help us do that calculation, please? So I'm waiting for the response. 2 raised to power 16 minus 2. Let's help us. Who will help us with that? If you have calculator with you. I'm waiting. I don't have calculator yet, and I want you guys to do it. So 2 raised to power 16 minus 2. Okay. 65534. Yes, great. So now we use that to get the number of hosts.
65534.
Yes, thanks so much. So we use that to get the number of hosts. Now, if we want to get the number of possible subnets we can get from this that we are doing. So what you will do is now let me try and write it out. So I have okay, so 255.0 0. Okay, can you hold on? I'm trying to do my calculation here. Will be 2 raised to power 8 to power 8. Okay. 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 So are we still together, please? I need the response. Are we still together?
Yeah.
Okay, I will take that as a yes. So now we've been able to know the number of hosts if we are using /16, right? So, but ideally now, what is the class of 10.0.0.0? What class does it belong to? Ideally now. In a class full addressing, what class is 10.0.0.0? I'm waiting for you guys. Okay, class A is in class A. Good. So it's in class A. And ideally, what should be the subnet mask for class A? Ideally, what should be the subnet mask for class A? Okay, ideally, the subnet class for class A, subnet mask should be 255.0.0.0. Now, let me go back to show you that. So we'll still come back to what we are doing. So talking about class, okay. So ideally now you can see for class A is /8. Did you see that?
Yes, sir.
Okay, so now if we are using /16, how many bits have we borrowed? How many bits have we borrowed by using /16 rather?
8.
And we borrowed 8. So now, if you want to know the number of subnets that you can derive from such subnetting you are trying to do, you will now do 2 raised to power the number of what you borrow. So that would be 2 raised to power 8. So 2 raised to power 8 will be equal to 256. So that's the number of subnetwork you can create out of 10.0.0.0. Then we've been able also to establish that the number of hosts per network, take note of that my emphasis, the number of hosts per network is 65534 hosts per network. That means I can create 256 subnetwork from 10.0.0.0 when I use /16. Yes, I can do that. So now let's now come to what we have. So now we have it as 10.0.0. So /16 now. So now the network address will be 10.0.0.0. That's the first subnetwork. Then the host range will be between 10.0.0.0.1 minus 10. Let me try and point out to where I'm talking about. I'm talking about this line. So we can see the range of the hosts. So if you try to calculate the number of possible hosts, so if you start from 1, 2, 3, until you get to, and you know, when you get to 10.0, there's the 0, the 1, 10.0, the 0, the 2, the 0, until you get to 10.0.255.254. So you'll be able to get about 65,534 possible hosts from that network. Then definitely, like I always say, the last one will always be the broadcast address. So with this, I think you've understood. Now, let's now also go over if we use /24. If we use /24, we see, okay, now let me ask someone. Okwe have been silent. Is he still in the class? Okay, so Okwe, I'm asking you a question now. So if we are using /24, now, ideally, the IP address is 10.0.0.0, which is of 255.0.0.0. Now, we want to use /24. How many hosts are we going to be having? Okay, how many hosts are we going to be having? Hey, Abiope has slept. Okay, who else can help us? How many hosts are we going to be having? Okay, thank you, John. That's 254. So that means we're going to be having 254 hosts per network. So now, how many subnets can we extract out of this? Now, if you can see that ideally it should be 255.0.0, but we are doing /24. That means how many bits have we borrowed now? You've borrowed how many bits now? Oh, I'm waiting. How many bits have we borrowed? I'm waiting for you guys. Okay, we have borrowed 16 bits. So to know the number of subnets we can get, that will be 2 raised to power 16. So that will give us 65,536. So that means we can get 65,000 subnetwork. But for each of the subnetwork, we'll be able to accommodate only 254 hosts. So you can see a major difference that as we increase in the preface length, the number of hosts reduces. So now, one last thing now. If you are to write, take for instance, that's 10, we are using 10.0.0.0/24. If you are to write the subnet mask have now changed to 255.255.255.0 because you have borrowed you've borrowed 16 bits. So I wish I can. So that's just that. So I believe everybody is clear. Any question? So if I give you a network for you to subnet for me, you can do that, right? I'm expecting at least 2 yeses. If I give a network to subnet, can you subnet now? I'm waiting for responses. I will try, hopefully yes. So if you want to be sure you will get it if you try, after this class, go to the online resource and practice. So if you do not do your subnetting very well, if you like design any network on a packet tracer, or even try to design any network using physical devices, so it will be throwing error. So if you do not do your subnetting very well, it will be throwing error. So let me progress. So you can have as many subnetting. So you can see that the subnetting increases, the number of hosts you can accommodate reduces. So you can see from here, you can see from here, you can see from here. So this is very brief. So subnet is slash and slash 16 and slash 8. So I think all this we have talked about. So you can go and do this yourself. So this one is slash 16. So okay, and I think you can. So even if it's slash 17, what they mean is just the number of ones. So those number of ones, divide it into 4 segments, 8 per segment. Try and convert the one, okay, this 17, this slash 17 now, what it means is that you have is like 1 1 1 1 1 1 1 1, then another set of 1 1 1 1 1 1 1 1. So these are 8 ones, these are 8 ones, making 16. Then there's another one here now, that's 17. So the rest are 0 0 0 0 0. So 0 0. So this one definitely is 255. This one too is 255. So if you try to convert normal binary to base 10, so if you do 0 times 2 raised to power 0, 3 raised to power 1, 3 raised to power, so this one will be, I think this one will be 2 raised to power 7. So that will be 2 raised to power 7, that will be 128. So this one will be 128. Dot, the other one is 0. So this will be the subnet mask. So it's just as simple as that. So that is just that. Okay. So let me progress. So I think every other thing in this slide is just I'll just rush through. Go and do your I'm rest assured now that I've done my homework by putting you through what I've done tonight, maybe this evening. So these are just like, take for instance, they're asking you to create 1,000 subnets. So the idea behind what I just told you is that, now imagine they ask you to come and to set up a network where there's most likely of them to have about 1,500 hosts. Let's say, for instance, 1,500 hosts. So in that kind of place, you know that, oh, I need to reduce my previous length because it's like, oh, it's going to be so much. You can't use /29 for that. You can't use /28. So you have to do your math well. So networking is not just a plug and play. You sit down, design it on paper, then you now configure. A poor design will lead to a frustrating, a poor work done on paper will lead to a frustrating design when you are configuring. So you don't just IP addresses. So after this class, you have come to understood that IP addresses are not just applied by just closing your eyes and you select. No, they are carefully selected. They are carefully selected. So subnets to meet requirements. So it depends. It depends on what you want to do. So this section will soon end now. I'm just trying to rush through. I've done. So you have to look at the number of hosts, the number of individual subnets needed before you do your design. So these are just example. These are just example. And okay, now you can decide to use different. This is what we call variable length subnetting mask. So VLSM. So you can vary your previous length depending. So you can see here now that between these two routers, I use the subnet mask of /27. So now I can decide to use, I think it was further modified. I can decide to, okay, yes. So since I only have a router here and a router here, definitely I'm dealing with only 2 hosts. I don't need to use a high, extremely high, a low prefix, and maybe now have high number of hosts it can accommodate. I don't need that. So you have to carefully select them. So look at your design. So I know that here I just need only, so I can even use, in some cases, I use /30 here because I know /30 will still give me 2 hosts. And that still further reinforce the security, because if I've statically assigned those 2 available IP addresses, for instance, maybe I have 2 hosts available based on my design, and I've assigned this to the port on that network. Even if you try to breach, if you try to mask like an host, there's no any available IP address for you. So there's another security approach, security method. So you can vary you can vary it. So I think that's just all that I would like to share with you guys today. So it's left to you. Go and do your assignments, go and study more and practice. In short, all we have said in today's class, if you go and sleep on it, close and unquote, you'll be surprised by Monday you've forgotten also. As we are finishing the class now, go and you can even watch online video tutorials. So thanks so much, and that marked the end of today's class. Any question?